Hi Chandaka,
Hello, Avi.
how are you?
Good, not bad.
So I have something here for you.
Mm-hmm.
Look at this guy.
Ah,
What is this?
looks very interesting. Looks like some sort of a weapon,
Weapon.
because you see a sharp end,
Huh.
and then you see another structure,
Okay.
right, to propel that
Huh.
sharp end somewhere
So it could be a gun or something.
from long time ago, right?
So let's look at it. There is some more hints here.
So it's two parts.
Yeah, so there is a
Oh.
mobile member and then a fixed member. See, finally it could be a weapon.
It still could be a weapon, right?
Yeah,
Mobile means could go.
yeah.
Really.
Or it could be a weapon for an engineer.
This is true. I have the feeling it is a weapon for engineer.
So what do you think?
Well, if there's a movable member,
Yeah. So that means this is fixed.
right?
This I can move left or right.
Okay. And there's a fixed member.
Yeah, and I see some terminals here. Probably I can take some electrical output.
Okay. So I get the feeling that maybe there's some relationship between this movable member and fixed member.
Fixed
I mean, why is one movable, why is one fixed,
Okay.
right? And you can move it, you said left or right.
Okay.
Right.
So that means when I move this here, I mean, maybe if I am measuring output at this terminal,
Mhm.
maybe I should get some output like this. Let's say I have an electrical circuit to measure from there and get some output voltage.
Okay.
Let's say I'm guessing.
Right.
And you had mentioned, see, there is a fixed member, there is a mobile member. And if it's true, I mentioned there are some terminals here, right?
Right.
If you are guessing, maybe I, being an electrical engineer, could be that, okay, we get some output voltage with respect to the displacement.
Yeah. So what you're saying is when you move the movable member,
Yeah.
you might get some
output. We don't know.
Right.
Yeah. So anyway, the title now says it's a linear position sensor.
Aha. Okay.
What it means?
I think something to do with displacement.
Yeah, displacement.
To measure displacement somehow.
Yeah.
Okay. So how far this movable member moves with respect to the fixed member? Or?
Yeah. One thing I wanted to know, what is there inside?
That's a good question. Yes, because curiosity. You said we are electrical engineers.
Correct.
If we are getting an output, there must be something inside.
Yes. I mean, I was guessing, I saw only a couple of terminals here. I don't know whether I will get an output. It was only a guess.
Right.
Finally, we may not get
anything.
Yeah. We may have to attach something to that.
Yes.
So, since you said displacement sensor or something that gives output
according to how much something is displaced from a reference point, maybe, I guess.
I was looking at the website. I mean, just randomly I searched for displacement sensors. Then I actually got some other images. This is one. This is another one. Now I am totally confused.
I mean, this one looks a little bit similar, right? There is a thing that can be, looks like there's something that can be moved.
Yeah.
And then it's inside.
So there, this could be the fixed member. And this one seems to be the mobile member.
That's what it seems like compared to that one.
Yeah. You also have seen something with a spring.
Yes. I can see some springs there. Correct. That's interesting. So, so if that is pressed, come back to
yeah. So I think in a normal position, it will be fully outside.
Okay. Right.
And when you measure, maybe you will just press it and see how much it does.
So compression then.
Yes.
Right.
Or the zero position is always the full scale.
Right.
Looks like.
Right. So what is that then? Is it displacement or?
It's also displacement.
Right. Due to some external.
Yeah. What about this?
It looks like a capacitor.
Yeah.
But it's not. But
because I don't see any fixed member, mobile member. Yeah.
This is true.
right? So I can at least see, two surfaces, one here, the outer surface, and then one inner surface. So could be a different way of measuring this displacement.
Right. Relative to each other.
Yeah. So the conclusion is, it seems to be a displacement sensor, this one. But there are different ways of sensing displacement.
Right. I guess different principles
Yeah,
of
different
measuring the same thing.
Correct.
And then the structure will then also differ.
Correct. Yes. So here, for example, you said capacitive. I don't know. Maybe.
Yeah.
This one could be something else.
Yep. Inductive.
Yeah, inductive. So we will figure out these things later.
Yeah.
How this works. Are they really capacitive sensing or inductive sensing, etc.? We will see that in detail. As a first step, we will cut open this and find out what is inside.
Okay. The most, I think, the mechanical of
Yes.
structures, right?
Yeah. So I did that operation. I don't have that figure here.
Oh, you open one up?
Yes, I opened. Then what I found is it's a resistive layer inside, or a resistive parts are used.
Okay.
So I was discussing with the student. There is if at all you want to use a resistive element as a displacement sensor, how will you do that?
Well, can't you use just a wire?
Correct. So like you see here, we know the expression for resistance, just rho L by A.
Yes.
So I can decide to use maybe, I change the L. So I get a resistance change directly proportional to the displacement.
Correct.
Looks easy.
Yes. Area remains the same.
Yeah.
And you change the L.
Yes.
And then that's proportional to?
Yes.
Yeah, resistance. Correct.
So that's an easiest way to form a resistive displacement sensor, which probably gives a linear output. When I say linear output, I change displacement, let's say at a constant velocity, my output will also increase at the same rate.
Right.
Or like I've drawn earlier, this will be a straight line with respect to displacement.
Right. Correct.
I could do, change in resistivity, but that may be a lot of work.
Yeah.
Or change the cross-section area. This means physically you will have to make some changes to the resistive element.
But that's a little bit complex.
Yeah.
Right? You have to play with the structure.
Yeah.
Somehow the area has to change as you move this along.
Correct. And those kind of actual dimensional change I don't want to make. Means I need to use the sensor repeatedly.
Yes. Correct. Yes. Possible, but not
possible,
really practical.
Possible. Yes. Yeah. So probably this may be the easiest way to make use of this factor to realize a resistive linear position sensor.
Right.
But you initially said just a wire.
Yeah.
Could do.
Why not a wire?
So inside, can I just have a wire like this? This has some resistance R. And maybe I'll measure from these two terminals, A and B. Will it be like that? No. Because it always gives the same value of S.
R has to change.
Correct. Right? Correct. So that means if I have, let's say, a movable member which is moving, then I need to mechanically link somehow.
Somehow touch.
Correct.
At a certain point.
Correct. Right. Yeah.
Then?
And then maybe I can either measure the resistance or make a voltage drop and then measure that voltage.
Okay.
Or what we are saying is...
So now you're adding something now.
Yeah. So I will draw separately. So we said this resistance.
Okay.
So now what I'll do is some more space I need. Let's say A, B. I connect a voltage source there.
Mhm.
Now, if this wire between A and B, if that's uniform,
Okay.
then this voltage Vs
Mm.
is dropped across this uniformly. Let's say the length is L.
Mm.
So total voltage is dropped across L. So for a unit length, I will have a voltage drop of Vs by L.
Depending on how small.
Correct. So now what we are saying is somehow introduce a mechanical contact to this.
Okay.
And you move that contact left or right depending on the movement of this movable member.
Okay.
So I'll have a better figure later, or I think there is a better figure here.
Mhm.
So as you see, there is a resistive element here.
Yes.
And then diagrammatically it is shown, okay, with respect to the, let's say this is the housing which is holding this resistive element AB, right? And inside which I have a plunger that can be pulled out or moved up or down.
Okay.
So then this contact point moves up or down.
Right.
So the electrical point at which I am contacting this strip AB is changing now.
Okay.
So earlier we said you have a voltage drop of Vs by L per unit length.
Over AB.
Yeah. Over AB we have Vs.
Yes.
So if I move, let's say this is 10 centimeter and I have Vs equal to 10 volt.
Mm.
So that means every centimeter I move, I will have a voltage change of 1 volt. Example.
Correct.
Right?
Right.
So let's say this is 10 volt. And let's say L is equal to 10 centimeter.
Mhm.
Right? So as per this diagram, this is at ground potential. So if I'm at the center, I will have 5 volt.
Okay.
If I'm at 2.5 position, I'll have 2.5 volt and so on.
Right.
And 7.5 volt and so on.
Yeah.
So basically, now I'm getting an output voltage at this point with respect to the terminal B.
Yes.
As I move from, let's say, from B to A.
So B is 0.
B is 0. When this terminal is at A, you have the maximum voltage 10 volt.
Correct.
So the resistive strip that you said could be used like this.
Yes, because now by adding a third component,
Huh.
you're changing the length.
Correct.
Right?
Correct. Exactly. So the length that we mentioned here is changing, or the point at which you are contacting decides the length L.
Yes.
Right.
Yes.
So in this case, more precisely, the displacement that you are measuring is this.
Yes. So is it fair to say then when this is fully inside,
It will be 0 volt.
will be at A or at B?
Yeah. When the plunger is fully inside,
Or here?
yeah. So maybe to give a connection to this, B will be here and A will be here.
When it's fully inside.
Yeah.
Yes. And then you pull it out.
Correct. So it could be something like this. But do you really think there will be just one wire like this, A and B?
I mean, technically it could be, but
Could be.
I'm thinking, I mean, that resistance will be, if it's a thin wire,
Yeah.
will be quite high, no? Small cross section.
Yeah. If it's actually a very thin wire,
no, sorry. Yeah.
Actually,
If it's thin wire, it will be low.
or if it's a thin wire, there is another practical problem.
Right.
Because I need to make a physical contact.
Correct.
Correct? So I have a thin wire and I need to make a contact to this.
Oh, yeah. Then that's
So, and I will
it
be
might bend even.
also, I'll be moving left, right.
Yes.
Several times I wanted
It
to
might
use
break.
this. It may break. So, physically, there can be a issue that way. So, we need a reasonable thickness.
So then can you get a thicker wire?
Of course, we can use a thicker wire.
Or several layers of wire.
Yeah.
Or something like
Yes. So now there is a question. Should we need more number of, whether, see, the length is fixed. Total length is fixed.
Yes.
Or for this movable member, the range at which you can move.
Yes.
For example, in the example that we have taken, we said
10 volts.
10 centimeter.
Yeah. And the total is 10 volts.
10
10
volts.
centimeters.
Yeah. So range is 10 centimeter there.
Yeah.
So the length is fixed.
Yes. So that could limit the,
Yeah.
right. How much
If
you
it's
can
a
take up.
straight wire, and you also looked at the output. So if you want, let's say for a same change, if I want more output,
right,
I will have to increase the VS.
Yes. 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 That's correct.
Because for unit length, it is VS by L. That's the equation you got. Yes. So when I increase voltage, and this terminals, RAB, A and B has got some resistance, RAB. So there will be something. So if I increase the voltage, there will be a little bit of heating, correct?
Yes, of course.
It's also a resistive element. You are applying voltage. There is V square by R.
Yes.
Power loss.
Yes.
So ideally, you don't want to waste a lot of energy to make a measurement.
And it gets heated up.
Correct.
That could also affect the resistance.
It can.
Depending on the material.
Yes, it can affect the resistance. It can affect its lifetime itself.
Yes. Yes.
And you are, losing energy for the measurement purpose.
Correct.
Ideally, we don't want to use any energy, but that is not possible, but we may. So that means the RAB, if it is higher, it is better.
Yes.
Right? Means I can have more voltage I can apply. So the V square by R losses will be low. Now, given this L range, how can I have more resistance?
That's a good question. We have to play
with one straight wire is not possible. So obviously you will have to coil it, something like this. So I have a structure, a bobbin. On which, if you wind several turns, then you have the A here, B terminal here, and the mobile terminal I drawn is this one. Right. We call it as a wiper. So let this be C. So now we have achieved higher resistance value in the given space.
Yeah, 10 centimeters, but still we have more.
Correct.
So these coils, are they wound very closely to each other? Or does that make a...
Yeah. So, I don't know. It's actually a good question.
Because before you remember the picture you showed, you had a spring, and that is not what we're talking about here, right? We're talking about increasing resistance by winding.
Yes.
Right.
Yeah. So what you're saying is, suppose if I wind with lot of gap, that means, let's say my wiper is here one time.
Yes.
Next time my wiper can be here.
Right.
Right. There is no contact.
Yes.
Correct?
If it's too far apart,
it's the worst case.
But this is an extreme case.
That's extreme case.
Here you can see, right? The wiper size is large enough to always touch something.
Yes.
Right?
Yeah.
But it just crossed my mind.
Yeah.
I also don't know the answer to this.
So the point that you are making is the wiper size, the wiper has got some width.
Yes. That has to
be selected in a way that before you leave one turn, you should make contact with the...
Exactly. Otherwise, there will be no output.
No output. You don't know where you are. How much is the displacement? We don't know.
Correct. Yeah.
So, that way, if you wind very close, then you don't need a wider wiper.
Yes. Correct. Yes. And your whole device can be smaller.
Yes. Yeah. Correct. But there may be more to understand on this, but this is a very nice point. So, we could make winding like this, and they are called as a wire wound. See, I'm sure your students have used this in their previous experiments. There is a resistive potentiometer they have used to get a voltage divider, or sometimes to have a filter whose cutoff frequency want to change. So variable resistors people have used.
Yes.
So it's a very similar thing. There they had a screw where they change, and then at that time this contact was actually
moving back and forth.
Yeah. We could also use it as a displacement sensor.
Right.
That is all we are saying.
Right.
Now, let's analyze maybe a little bit more. Yeah, by the way, one of the typical materials that is used is nichrome. It has got good resistivity.
Mm-hmm.
You were actually mentioning about temperature. So, I'm not sure whether, temperature we mentioned, the life span may get affected
because it gets hot.
Yeah, it gets hot. Power loss, like that. Power loss is there.
Mm-hmm.
But will it give a wrong reading? That I'm not sure.
Because you're looking at 2 points.
Yeah.
And if it's gone with the same wire, then that should not.
Yeah. Because the total resistance, let's say that is RAB, let's say at room temperature.
Yeah.
And if the temperature increases, there is, of course, we know there is something called temperature coefficient of resistance.
Yeah.
Maybe students can check for nichrome what's the temperature coefficient of resistance. I think it's 0.0004.
Something very small.
Please check it. Yeah. Now, there will be an increase in resistance.
Correct.
That means with the increase in temperature, RAB will increase.
Right.
We said one thing, the output voltage per unit length is Vs by L. L is the total length.
Correct.
I have not changed Vs. I have not changed L.
Yes.
So that will not change.
Yes. And you are using the same kind of wire.
Correct.
So resistivity should be the same.
Yeah. So, or the voltage drop per unit length will still be same.
Yes.
With the assumption that the whole portion of the sensor is heated equally.
That is also a good point.
Yeah.
Yes.
Yeah.
Yes.
For example, let's say the heat is only in this areas. Then there alone the resistance will be more.
Correct.
Here this will be cooler.
Yes.
So that can create some issue in the output.
Yes. Correct. Compared to a big device like this could happen. But some of the images of the...
Yeah, I have seen such kind of things with even 1 meter displacement.
So in that case, one area will be exposed to higher temperature.
Yeah.
But if it's small, then chances of this happening is very low.
Yes. But there is a possibility.
There is a possibility, of course.
So the point is, as long as the heat is applied to everywhere, since you are using this voltage divider mechanism, the whole resistance RAB will increase. So volt per unit will still remain same. So my output voltage will not change with respect to temperature.
Right.